All right, we're going to look at question number 16, and 16 says find an equation of the tangent line to the graph of this function, and they tell me that x has to equal 1. So the second I see find an equation of a tangent line, I'm going to write down for myself y minus y1 equals m times x minus x1. All right, so far, let's change our color. And so far, they have given me the x1. So right away, I have x minus 1 without doing any work. All right, the next thing I'd recommend you doing is finding the y1. Okay, y1 is going to be the original function evaluated at 1. So I haven't taken any derivatives yet. So look at your original function. Wherever you have an x, put in a 1. Okay, so you should be doing this along with me. All right, so 3 times 1 is 3, plus 2 times 1 is 2, so that's going to equal 5. So now I know that I have a 5 here, and I'm ready to tackle my derivative. So this slope is the derivative of this function evaluated at 1. So I'm going to change colors again, and we'll work on getting that derivative. So f prime of x equals 3 times 3 is 9, and then x squared plus 2. Okay, there's nothing fancy about this. There's no chain rule. There's no complications. So now go ahead and evaluate that function, which is your derivative, where x is 1. So 9 times 1 plus 2. So 9 plus 2 is 11. So I'll change again just to be consistent. And 11 is my slope. That is the equation of the tangent line to this graph at x equals 1. Okay, we're going to, in just a sec, we're going to do 17. Okay, question 17 is also a find the equation of a tangent line to a graph, but this time you have a trig function, and you have an angle that's going to go into that trig function. So I would still recommend that you write this down for yourself first so that you know where you're going to get a tangent line. So what do I know so far? I know my x is pi over 3. So right now I'm going to put pi over 3 for my x1, and I have x minus that. I need the slope. I don't know my y1 yet, but as is my normal form, I'm going to get that first. So your y1 is your original function, so your f of x, evaluated where x is pi over 3. So let's figure that out. So just plugging it in, I see that I have sine 2 times x. So I'm going to put pi over 3 right here. And then I'm going to add 3 to that. All right, so this calls for a unit circle. So when you do a unit circle, you've got to be able to call this up pretty quickly. So here's what I'm going to do. This is pi over 6. Pi over 3 is up here. That's what we need. So I'm just going to tell you that the coordinate pair is up there, and I'm going to leave this for you to figure out. But if I count 1, 2, 3, the top one's going to be 3 over 2, and that's going to be radical, and that's going to be 1/2. So that's my coordinate pair. I need 2 pi over 3. Okay, 2 pi over 3 is just going to be in the second quadrant. So where will that be? If this is where pi over 3 is, well, let me see. I've kind of gotten this a little crooked. So let me fix this and get right back to you. Okay, I cleaned this up a little bit for us. So I can see that 2 pi over 3 is in the second quadrant. So sine of 2 pi over 3, let's see, the second quadrant, that's where sine is positive. So therefore, go to your reference angle, which is pi over 3, and you're going to grab the sine, which is going to be root 3 over 2, because that's going to be where the sine is, right? The cosine is the x, the sine is the y. So since it's positive, I know that this value right here, the sine of 2 pi over 3, is going to be root 3 over 2. And then you're going to add 3 to that. So I'm not going to get overly fancy with this, but it would be nice to have this as one fraction. So how will I do that? What if you take your 3 and multiply it by 2 over 2? Doesn't this term then become root 3 plus 3 times 2 is 6 all over 2? All right, so that's what I'm getting for my y value. So I think what we'll do is I'll go to the next page and copy some of this over. So stay tuned for just a sec. Okay, so I cleaned up this a little bit by removing that unit circle for the time being. So what I want to do now is I want to take this value, because this is equal to my y1. So in terms of my tangent line, I'm going to put y minus radical 3 plus 6 over 2. All right, all that's missing is my slope. So I get my slope by taking the first derivative of that function. So let's do this in a neater way as well. So I'm just going to draw a line here, and we'll start working down here a little bit. So I know my initial function was f of x equals sine 2x plus 3. All right, let's take that derivative. F prime of x equals, the derivative of sine 2x is cosine 2x times the derivative with respect to x of 2x, which is just 2. So my full derivative is going to be f prime of x equals 2 cosine 2x. Now what about this 3? That derivative is just 0, so here is our final derivative. So now we have to evaluate that at the angle of pi over 3 so that we can figure out a value, and that value will be our slope. Okay, so let me just put another little line kind of right here, and I'm going to just erase this little thing, and let's do some work over here. So this is what I want to do now. I want to say, what is f prime of pi over 3? So just plugging it in, it's going to be 2 times cosine 2 and then pi over 3. So remember, we just talked about the unit circle with pi over 3, with 2 pi over 3, excuse me, and we can go back and look at that. So I'm going to have a 2. That's coming from this. I now need to replace cosine 2 pi over 3. So let's flip back for a second to the unit circle. So here's 2 pi over 3, and in this quadrant, cosine is negative, so it's going to be a negative value. Go back over to your reference angle, which is pi over 3, and grab the 1/2, but make it negative 1/2. So now I'm going to plug in, for this value, cosine 2 pi over 3 is going to be negative 1/2. What happens now is that the 2's cancel, and I'm left with negative 1. Negative 1 is my slope. So let me erase my slope holder right here, and we're going to put in a negative 1. This is your equation of a tangent line. It may be messy looking, but we did it very systematically, and that is your final answer. So now we're going to go on and do question number 18. Okay, question 18 says, find all the points at which the graph of f of x equals, whoops, sorry, let me undo that, get my pen back again. Okay, for where f of x equals x cubed minus 3x, and it has to have a horizontal tangent line. So, first things first, if you have a horizontal tangent line, what is that slope? So that slope should be 0. Alright, so find the slope of this equation. That is just your first derivative. So take your first derivative, and I'm getting, and you should be getting, 3x squared minus 3. Okay, that's the derivative of x cubed minus 3x, the function that's above. So now I want to know, where does this slope equal 0? That does not mean I'm going to plug in a 0 for x. It means I'm going to take this equation, that was my f prime of x, and I'm going to set it equal to 0. So where does that happen? Let's see. So, so far, what I could do is, let's see if I like to do this. X squared minus 1 equals 0. So what did I do? I factored out a 3. So 3 can never equal 0. That's a number. So where does x squared minus 1 equal 0? Well, can't I factor that also? And isn't that x plus 1 and x minus 1? So set those equal to 0, and I'm getting x equals 1 and x equals minus 1. Do you see that? So they want points, not just x values. So points are coordinate pairs. So far I know that my coordinate pair is 1 for one of the points and negative 1 for the other. So let's figure out what the y values are. So take your 1 and plug it in your original function. 1 cubed is 1, and 1 minus 3 times 1 is 1 minus 3, so that's a negative 2. Okay, now let's try the negative 1. Negative 1 cubed is still negative 1. So this is negative 1. Now negative 1 minus, what is a 3 times a negative 1? That's a negative 3. So it's negative 1 minus a minus, so that's plus a 3. And negative 1 plus 3 gives me 2. And there you have the 2 points. So find all the points at which this graph has a horizontal tangent line. We took the derivative, set it equal to 0, and I found my 2 points that make that true.